Hello and welcome to this section of the chemistry tutor. Here we're finally going to start to get into a little bit of the math behind the ideas we covered in the last section. We're going to do several problems dealing with really calculating the concentration of these ions that are in solution. So remember, we have something, we add it to water, it dissociates, breaks down into these ions. These problems are going to be dealing with calculating the concentration of these ions in the solution. So the first question is written on the board here. What is the molarity of lithium ions in 0.0385 molar lithium nitrate solution? So anytime you see something, a number, molar lithium nitrate, this means this is a solution. We've mixed some lithium nitrate with water. We've got a concentration of lithium nitrate. The molar, the M, means moles per liter. Right? So this means that I have 0.0385 moles for every single liter of the solution that I have in my chemistry cabinet or whatever. If this is unfamiliar to you, if you don't remember what molarity is or anything, then go back please and review that material in previous lessons, because it's just going to make your life so much harder if you're not really familiar with those concepts. And we've covered them all before. Okay, so the question is, we know the molarity of the solution, but we don't want to know that. We want to know what is the molarity, which means concentration, of the lithium ions in the solution. What's the concentration after it breaks apart? What's the concentration of the lithium ions in solution? So my advice that I follow myself working these problems is first write down a little chemical equation to kind of clear your head. So this is the lithium nitrate. We're going to add it to water, right? What happens when we add it to water? Well, it's going to split up. Now this is not sodium chloride. Remember we talked about sodium chloride. It splits into sodium and it splits into chlorine. Your first thought might be, well, this is going to split into lithium ions, nitrogen ions, and oxygen ions. But actually that's not true. This NO3 is a very stable ion called a nitrate ion. So what's going to actually happen is the lithium is going to split up into the lithium ion, okay, plus the NO3 is going to be kind of like one grouped unit together. It's going to be a negative ion with a -1. So if you kind of go in reverse back to chemistry 1, the very first lessons we did, we said what happens when you combine lithium and the nitrate ion, and you said, well, lithium has a charge of +1, nitrate has a charge of -1, so we learned how to use that information to say it's going to form this. The exact reverse is happening. We stick it in water, it's going to split off into these kind of constituent ions. So, by the way, what's the cation and what's the anion? The negative ion is the anion. So the nitrate ion is the anion. The lithium ion is the cation. Now, just like any other chemical equation, everything has to balance, all right? So we make sure it balances. One lithium, one nitrogen, 3 oxygens, 3 oxygens. So we haven't really violated anything. They're just splitting apart. But as far as the atoms that are present, everything is already accounted for. So this is already a balanced reaction. It's not really a reaction, but a balanced dissociation. So in order to calculate, what we want to know is what is the concentration of lithium ions in the solution. So you can set up a calculation just like anything else. We start with what we know, 0.0385 molar of this stuff. So the way we write it is 0.0385 molar means moles of lithium nitrate per 1 liter of solution. This is how I want you to write it. When you see molar anywhere in any of these calculations, I want you to not just see it as molar, see it as moles per liter. Moles per liter. Moles of what? Moles of this lithium nitrate per 1 liter of solution. SOLN means 1 liter of solution. Now what we're trying to do is calculate the concentration of this, the molarity of this. So we know that for every 1 mole of lithium nitrate, we should yield 1 mole of lithium ions and 1 mole of nitrate ions. Right? So for every mole of this, it breaks apart. We should get a mole of this and a mole of this. That's just given by what we have on the board here. So we can use that conversion factor, and we can say 1 mole of lithium nitrate corresponds to 1 mole of lithium ion. And we write it this way instead of upside down because we're trying to cancel the moles of lithium nitrate with the moles of this. So what do we have at the end of the day? 0.0385 divided by 1 multiplied by 1. So what we're going to get is 0.0385. What is the unit? Moles of lithium ions per 1 liter of solution. Per liter of solution. Moles per liter, in other words. What happens when you have moles per liter? What it means is you have 0.0385 molar lithium ions. Okay? So anytime you have a big M like that, it means moles per liter. That's the unit we got in the end, so that's what we're trying to find out. Now notice the number that we get is exactly the same as what we started with. So you might say, well, what does that make sense? Well, it does when you think about it. What is a mole of something? A mole is 6.02 times 10 to the 23rd fundamental units of whatever it is you're talking about. Here we have, if we have a mole of this stuff, this is bound as a, as a unit, right? If we have a mole of this stuff, when it breaks apart, for every one of these, as these guys that goes into solution, it should break apart to 1 lithium ion and 1 nitrate ion. So for every mole of these things that go into solution, we should get 1 mole of this and 1 mole of this. So concentration-wise, what we're saying is that for every 0.0385 moles, take 1 liter of solution. This is a concentration, it's moles per liter. So just take, all things being equal, if you only have 1 liter bottle, if we have 1 liter bottle of this stuff, we should have 0.0385 moles of this stuff, and we should have 0.0385 moles of lithium ions, because for every one of these things that goes into solution, it breaks apart into a lithium ion and a nitrate ion. So it makes sense that since this breaks into a 1-to-1 ratio, that however many moles we stick in should be however many moles we get out of lithium ions. So the concentration, in other words, of the lithium nitrate solution is the same as the concentration of the lithium ions in there. So hopefully that makes sense in your mind. If the logic doesn't make total sense, then you can just fall back on your units. We know we start with 0.0385 moles of this for every 1 liter of solution. We also know that for every mole of this, it splits into 1 mole of lithium ions. So we set up our conversion factor. 1 mole of what we start with yields 1 mole of lithium ions. This cancels. The only units left over is moles of lithium ion per liter. Moles per liter is capital M for molar concentration. And that's what we're asked to find. Okay? Now the second question is very similar. We want to find the concentration. When you see somebody say, what is the concentration of something, it's the same thing as asking what's the molarity. Molarity, concentration, really the same thing. What is the concentration of chlorine ions in 0.035 molar CaCl2? CaCl2. So what is the concentration of chlorine ions in this concentration of a compound called calcium chloride? All right. Well, the first thing you do is you write a little dissociation for what we have going on here. If we take calcium chloride and we put it in water, then we should get calcium, okay, plus chlorine, which is -1. Right? If you look at the periodic table, you're going to see that chlorine wants to have a charge of -1. So you might say, well, we're done. But then you look at this and you say, is this balanced? Okay, we have 1 calcium, 1 calcium, 2 chlorine, 1 chlorine. Clearly this is not correct because we have more chlorines on the left than on the right. Well, this, even though it's not really a reaction, we don't have anything reacting, but it is describing what's happening when we put the things in solution. It still has to balance, just like any other reaction. The way to balance it is just to put a 2 here. Okay, so what this is saying is that for every calcium chloride entity that goes into solution, we're going to yield some calcium ions and we're going to yield some chlorine ions. For every 1 mole of this that goes in, we're going to get 1 mole of calcium and 2 moles of chlorine. The reason we get 2 moles of the chlorine ion is because we have 2 chlorine atoms tied up. So for every 1 unit of this that goes in, we should get 1 mole of calcium ions, and we should get 2 moles of the chlorine ions because we have 2 atoms here. So it all makes total sense. You just need to make sure that it's balanced because we're going to use these numbers in calculations. So we want to find out what is the concentration of the chlorine ions. All right. So doing it, with our math, we start with the concentration of what we know, 0.035 molar, which you need to translate to moles of CaCl2 per 1 liter of solution. This is how I want you to write it in all of these cases. So don't write molar down. That doesn't really help you. You need to break it down to what it means. 0.035 moles of CaCl2 per 1 liter of this solution. Okay? And then we use the conversion factor wrapped up here. We know that 1 mole of calcium chloride yields 2 moles of chlorine ions. So we're going to use that. We're going to say 1 mole of calcium chloride corresponds to 2 moles of the chlorine ions in solution. The reason we did it that way was so we could cancel moles of calcium chloride with moles of calcium chloride. The only unit we have left is moles of chlorine ion per liter, moles per liter. That is a concentration, it's a molarity, okay? So we take 0.035, multiply by 2, and what we're gonna get is 0.07, the unit is moles of chlorine ions per liter. I'm just gonna call it liter of solution, which is 0.07 molar of chlorine ions. 0.07 molar. So when you see molar, you should translate it in your head to moles per liter. Okay? Moles per liter. Okay, for our next problem, we actually have it already on the board here. It looks long and complicated, but you'll see that it's not too hard. So what we have is we're given that seawater contains a certain concentration of sodium chloride, which is table salt, and a certain concentration of magnesium chloride. Okay? And the concentrations are given to us, 0.438 molar NaCl, 0.0512 molar magnesium chloride. And it's asking us, what are the concentrations of the sodium ions, the magnesium ions, and the chlorine ions in solution? All right, so the first thing to do is just think about it for a second. You've got sodium chloride that's going to go into water, and it's going to break apart into sodium ions here and chlorine ions, which were asked for here. The magnesium chloride is going to break apart into magnesium ions, which were also asked for, and it's also going to break into more chlorine ions. So the answers that were asked for, we're going to calculate these straight away, but we need to be careful with chlorine because the sodium chloride is going to give some chlorine. The magnesium chloride is also going to give some chlorine. And so we're going to need to sum those together in the end to find the total concentration of these guys. So let me also say quickly, I'll introduce something to you. Anytime you see a bracket like this around something, it means what is the concentration? It's another way of saying what's the molarity. Moles per liter. It's the only thing. So I'm just kind of introducing it to you because some books are going to ask you, find this, and you're going to need to know what does the bracket mean. It means concentration. All right, so we're going to use that. Now let's go ahead and write some of these guys down. First thing we need to do is first deal with the sodium chloride, calculate the concentration of sodium and chlorine that come about because of that, and then we need to, after that, deal with the magnesium chloride, and we'll do that in a separate calculation. So first, let's deal with NaCl. Okay, first things first. We know that NaCl breaks down into Na plus Cl negative. Okay, and this is balanced. Sodium, sodium, chlorine, chlorine. We don't have to add any numbers anywhere, any coefficients anywhere, because this is already balanced. 1 mole of this yields 1 mole of this and 1 mole of this. Okay, so let's figure out, based on the concentration we're given, what would be the concentration of sodium that is in solution and what's the concentration of chlorine in solution. So we start with what we know, 0.0438. So 0.0438 moles of NaCl for 1 liter of solution. And then we look at our little chemical equation we wrote and we see, okay, well 1 mole of this corresponds to 1 mole of sodium. So 1 mole of NaCl corresponds to 1 mole of sodium ions. And we construct it like this because we're canceling moles with moles. So really, there's not much math to do here because you got 0.0438 I'm sorry, that's not 0.04, it's 0.438. Like this, okay? You don't really do any multiplication because you're multiplying by 1. So what you're going to actually end up in the end is 0.438 moles of Na plus per liter of solution. So this is the concentration of the sodium ions in the solution due to dissolving this, all right? Let's go underneath it, switch colors, and do the same thing again. Now we're going to calculate the chlorine. So 0.438 moles of NaCl per 1 liter of solution. Okay, for every mole of sodium chloride, we get 1 mole of chlorine. So 1 mole NaCl gives 1 mole of chlorine ions like this. Okay, and so we cancel moles of sodium chloride, moles of sodium chloride. Again, we're doing multiplication, but really nothing has really changed because we're multiplying and dividing by 1. So what we get is 0.438. And the unit is moles of chlorine ions per liter. So it's moles chlorine ions per liter of solution. Now notice in these cases, I'm doing all of the math, explicitly so you understand. I mean, some of you might realize by looking at this that since this splits up into 1 mole and 1 mole, you can kind of just look at it and say, well, 0.438 moles of this is going to split into 0.438 moles per liter of this and 0.438 moles of liter per this, and just write it down. I'm showing all of the conversion with the math because mostly I'm trying to teach you fundamentally what's going on, and also I'm trying to teach you that even if you don't know what to do as far as have a roadmap to the end, you can use your units to get where you're trying to go. Cancel this and this. This is the concentration we're after. But certainly, if you see it without writing all that down, you can certainly do that. Now let's deal with magnesium chloride. Magnesium chloride. What would be the chemical equation here? So what we would have is magnesium chloride. Okay, it's going to break apart into magnesium, and magnesium likes to have a charge of 2. Chlorine likes to have a charge of -1. This comes from the periodic table. If you look at the column magnesium is in, it wants to have a charge of +2. Chlorine always wants to have a charge of -1. So we look and say, is this balanced? 1 atom of magnesium, 1 ion of magnesium, 2 atoms of chlorine, only 1 atom of chlorine. So we know we're going to have to do something here. And so what we do is we put a 2 in front of the chlorine, and this is going to balance it. And this makes sense because for every mole of this that breaks down, we should get 1 magnesium, and since we have 2 chlorines here, it should break into 2 chlorine ions. So this is a little bit different than what we had before because we have a number here for the chlorine. All right, so let's first calculate what is the concentration of the magnesium ions in the solution. What would the concentration of that be? So what we're going to start with is what we know. We know we have a concentration of 0.0512 molar of this stuff. So 0.0512 moles of MgCl2. That's what molar means, moles per 1 liter of solution. Okay, that's what we start with. And we know from this chemical equation here that for every 1 mole of this, we get 1 mole of the magnesium ions. So for 1 mole of MgCl2, we get 1 mole of magnesium ions. Okay, and so at the end of the day, when you cancel this and this, and you multiply, of course, it's just by 1, then what you're going to get is 0.0512 moles of Mg ions per liter, moles per liter, because we have liter on the bottom. So we're getting moles of magnesium ion per liter of solution. Okay, almost done. Now the only other thing we need to calculate is what chlorine concentration we're going to get. How many chlorine ions are we going to have? So again, we start with what we know. We know we have 0.0512 moles of magnesium chloride per 1 liter of solution. okay? And we know that for every mole of this, we get 2 moles of the chlorine ion. So 1 mole of MgCl2, we get 2 moles of chlorine ions. Don't let this slip by, because this is actually going to be a little bit different than what we had before. Make sure you set it up in a way that cancels everything, because now we have 0.0512 times 2. All right? And so what we're going to actually get over here is 0.1024. The unit is moles of chlorine ions per liter. So it's moles of chlorine ions per liter of solution. So this is a concentration of chlorine. So to summarize, we haven't gotten the total answers yet, but to summarize, we looked at the sodium chloride. We calculated how many sodium ions per liter of solution. We looked at the chlorine ions from sodium chloride and figured out how many chlorine ions come from that in a liter of solution. Then we looked at the magnesium chloride and figured out how many moles of magnesium we get per liter of solution. And we looked at the chlorine in this guy, magnesium chloride, and calculated how many moles of chlorine ions come from there in a liter of solution. So to summarize everything, the way you would write it on your paper, bracket Na plus, this means concentration of sodium ions, is 0.438. And you can write molar Na plus 0.438. It comes directly from the sodium that we calculated right here. I'm just writing it on the board. The next thing we write down, magnesium, the bracket means concentration of magnesium. We calculated that right here, 0.0512 molar magnesium. So that's moles per liter. And then finally, we calculate from chlorine, the chlorine ions. Now here's a little different. We have some chlorine ions coming in from the sodium chloride, and we have some chlorine ions coming from the magnesium chloride over here, actually. So what we're going to have is 0.438. 0.438 comes from the chlorine ions from here, plus we're going to add the chlorine that comes from there, 0.1024. And so what we get is 0.540 molar Cl negative, like that, 0.540 molar. And these are all the answers. So the question asked you, if you look back to the question, it says, what are the concentrations of the sodium ions, the magnesium ions, and the chlorine ions? It's a great problem because it forces you to look at 2 different compounds dissolved in water, right? And we look at the concentration of the first one to calculate what is being dissolved into the water, what is dissociating from the sodium chloride. We get that. Then we look at the magnesium chloride and we get what's being, what ions are going into solution from there. And then since we had chlorine contributed from 2 different places, we had to add it together. So in a liter of solution, you have this many moles of sodium ions, this many moles of magnesium ions, and this many moles of chlorine ions contributing there in the solution. Okay, now in this problem on the board, it's kind of interesting. We're going to need to use everything that we've learned so far, plus some logic to get to the answer. The question is, what volume of 0.0250 molar magnesium chloride solution should be diluted to 250 milliliters to obtain a solution with a chlorine ion concentration of 0.0135 molar? I'll be honest with you, when you first read this question, if you don't really know what to do, you stare at it and you're like, what are they asking me to do? I've got 2 molar concentrations, I've got a volume here, you don't even know where to start a lot of times. You need to kind of build a little bit of a mental picture of what they're asking you to do. Okay, you have a certain concentration of magnesium chloride in your cabinet, okay? You have a big giant jug of this stuff. When you see a molar here, it means 0.025 moles per liter of magnesium chloride solution, okay? And then what you're doing is you need to dilute this guy to 250 milliliters. So you grab this flask, you need to start with some volume that you're trying to decide on, and you need to take that and dilute it to 250 milliliters so that after you get to this point, if you measure the chlorine concentration in there, you're going to get this. So a lot of times in these problems when it's asking you, what volume would you need to do this? What molarity would you need to do that? You need to, a lot of times, start at the end of the problem and work backwards. In other words, don't try to think about how to calculate the volume directly straight out, because you're going to get lost and you're not going to know what to do. Instead, start with the end of the problem, what you're given as fact, and work your way backwards. That's really how you have to work a lot of chemistry problems. So yes, they tell us the 250 milliliters, but really the end game, the final constraint of what they're trying to tell you to calculate in this problem is given at the very last sentence. The chlorine concentration in the final solution has to be this. So you have to start with this in order to backtrack back to what you're trying to find in the beginning of the problem. All right, so before you can even do that, you need to have some idea of what this magnesium chloride looks like when you put it in water. So write yourself a chemical equation. Magnesium chloride, okay? And, go ahead and put aqueous solution here. It's going to dissociate into magnesium ions, which are always +2, and chlorine ions, which are always -1. But you can see this is not balanced because we have 2 chlorines and only 1 chlorine, so we need to balance it by putting a 2 here. This should make sense. For every mole of this, you should get a mole of magnesium and 2 moles of chlorine because you have a 2 here. So you should put a 2 out there. And of course, they break into, these are the anions, the negative charges, and these are the cations, the positive charges. Okay, now like, as I suggested a minute ago, you really need to start at the end game, all right? This is the end game. We know the chlorine ion concentration has to be this, so let's start with that. So what we do is say 0.0135. Don't just leave it like that. You have to see what is it. Well, it's a molarity. It's moles of chlorine ions per 1 liter of solution. Okay, this is how you translate anything when you have a big M, a molar. It's moles of something per liter of solution. In this case, it's moles of chlorine ions per liters of solution. All right, now I know I'm going to want to convert this to milliliters because ultimately everything else is in terms of milliliters. I'm diluting it down to so many milliliters and so on. So what I'm going to do next is I'm just going to simply use this guy, and I'm going to say 1 liter of solution is equal to 1,000 milliliters of solution. And that's perfectly legal to do because liters of solution cancels with liters of solution. Basically, all I'm doing is taking this, dividing by 1,000, and it's going to give me, instead of moles per liter, if I stop the calculation now, it'll be moles per milliliter of solution. Okay? So the only reason I'm doing this is because I have this other volume in milliliters, and I'm going to deal with that in just a minute. All right? Now, let me ask you this. What do you think would happen if I stop the calculation here? All I know is the concentration, the moles per chlorine in every single milliliter of solution. Now, if I multiply by 250 milliliters, see what happens is, forget about the first part of the problem. I know what's going to happen is I'm going to dilute something. I'm going to have 250 milliliters of the solution. And I know that in that 250 milliliters of solution, the concentration of chlorine ions must be this. All right? But I know that the final, when I do my experiment and I do it and fill it all up, I know ultimately I'm going to have 250 milliliters in a bottle of something. All right? So that's obviously very, very important. I know the concentration of chlorine here, but what I need to do is multiply by 250 milliliters of solution. Because when I do that, the milliliters of solution cancels with the milliliters of solution. What units do I have left? Here, I've canceled everything. The only unit I have left is moles of chlorine ions. So I'm not dealing with concentration anymore. When you have your concentration and you multiply it by a volume, then you don't have concentration anymore. You're dealing with moles of something. So now I know, if I stop the calculation now, that this is how many moles of chlorine ions are going to exist in this flask after I dilute it to 250 milliliters. That's how many moles of chlorine ions. Now, once I'm at the molar level, I can use the equation to jump from moles of chlorine all the way back to moles of magnesium chloride solution. So I'm going to do that now. So I'm going to continue this calculation on the next line. Unfortunately, I ran out of board space, so you have to forgive me a little bit. But the only thing I have on the top is moles of chlorine. And I know that for every moles of chlorine ions, for every 2 moles of chlorine ions, I should have 1 mole of magnesium chloride. So I have, with my equation, a way to jump from here back over to here. So I say, for every 2 moles of chlorine ions, I should have 1 mole of MgCl2. like this. Now let me go ahead and stop the calculation now and see where we end up. Let me go ahead and cancel this guy. Moles of chlorine on the bottom cancels with moles of chlorine on the top. This is on the top, this is on the bottom. You got to imagine this is kind of stuck on the end over there. So the only unit I have left is moles of magnesium chloride. So the only unit I have left is moles of magnesium chloride. So if I take 0.0135, divide by 1, multiply by 1, divide by 1,000, multiply by 250, multiply by 1, divide by 2, then what I'm going to get is 0.0017 moles of magnesium chloride. And I'm going to put in the bottom needed. What I've really calculated is how many moles of magnesium chloride I really need in order to do this. Because ultimately, what you basically have figured out is this is how many moles of magnesium chloride, pure magnesium chloride I need. If I dilute it down to this level, then I'm going to get chlorine ion concentration where I basically ended, where I basically ended up with the problem at the end game there. So the next thing I do, okay, is I start with what I have here and I try to go calculate, okay, if I know how many moles of magnesium chloride I need, what volume of this specific molarity magnesium chloride solution am I going to need to actually pull it off? So again, if you don't in your head know exactly how to calculate it, just use your units. 0.0017 moles of magnesium chloride. That's what I've calculated, right? Now, what else do I know? Magnesium chloride. I know my solution concentration of the original stock solution is 0.025 molar, which is moles per liter of magnesium chloride. So I could say 0.0250 moles of magnesium chloride for 1 liter of solution. All right, 1 liter of solution. So what I can do is then cancel this with this. And there's one more thing I'd like to do, just because our problem is mostly talking about milliliters. I'm going to continue my calculation down here, and I'm going to say that 1 liter of solution is 1,000 milliliters of solution. Okay, so I can just cancel liters on the bottom with liters on the top. Again, pretend this is kind of sandwiched at the end. Then what you're going to get is 0.0017 times 1 divided by 0.0250 times 1,000. All the units have canceled, so whenever you finally get the end of the day, you're going to get 67.5. What is the unit? It is milliliters of solution. What solution are we talking about? Milliliters of magnesium chloride solution. Okay, so let's go back from the beginning. We're trying to calculate what volume do we need to take of this concentration of the solution, such that if we take it and we dilute it down, whatever initial volume we start with, to 250 milliliters, the final concentration of chlorine is given there. So what it basically means is if we go to the cabinet and take 67.5 milliliters of this solution, 67.5 milliliters of that solution, 67.5, and then we dilute it, which means we add water to bring it up to 250 milliliters. So that's diluting the solution. We're taking the solution, which is 67.5 milliliters, we're adding water to it till it gets to 250 milliliters. Once we get to that point, at that point, the chlorine concentration should be 0.0135 moles per liter, which is molar, right? That's molar concentration. This is a fantastic example of using your unit conversions to get to the answer, because I'll tell you, it's difficult to map out ahead of time. When you read a problem like this, in chemistry, your initial gut is trying to figure out how do I get from the beginning to the end of the problem. And a lot of times it's hard to map your way there without having a lot of experience working with these problems. What you need to force yourself to do is write down what you know. You can write down this dissociation reaction. You're almost always going to need some kind of reaction or some kind of equation in chemistry to get anywhere. So you need to write that down. So boom, write that down. The next thing is you don't really know where to start up here because it gets too confusing, but you do know the end game, 0.0135 moles of chlorine per liter of solution. All right, I convert to milliliters here by canceling here because I know I'm dealing with milliliters, so I go to milliliters. Now I realize if I multiply by 250 milliliters, right, then If I stop the calculation right here, it's going to tell me how many moles of chlorine I basically have in that beaker after I dilute it. Now, once you're at the molar level, your goal a lot of times in chemistry is to convert yourself to moles of something. Because once you're to moles, you can use the chemical equation to jump from one part of the reaction to another. Here we got to moles of chlorine over here. So we use this equation to jump from moles of chlorine ions over to here, using the ratio of 1 to 2. Okay, we arranged it to cancel our units. Milliliters of solution cancels with this, and then finally moles of chlorine ions cancels with moles of chlorine ions there. So the only unit I'll have left is moles of magnesium chloride. All right, so what this means is I need this many moles of magnesium chloride, such that if I dilute it to 250 milliliters, I'll get the concentration that I basically know I have to have. Right? But obviously I don't have magnesium chloride powder I can just go pour in there and do that. I'm not given that. I have a solution, a stock solution of magnesium chloride that's already dissolved in water in this concentration. So I use the number of moles of magnesium chloride that I need, and I use the concentration of the solution that I have, arranging it like this, to figure out how many liters of that stock solution I need. I convert that to milliliters here, giving me this. So again, you start with the final concentration, you calculate to how many moles of magnesium chloride I need, then you use the initial concentration to get to the volume of the stock solution you have. And that's going to be a common theme that you're going to see throughout a lot of chemical computations. You're not really going to know exactly how to get to the final answer until you start playing around with it, but write down what you do know and start trying to convert units to get yourself up to moles of something. Then you can use the reaction to jump. See, we knew we had to get to magnesium chloride because we knew we were trying to find what volume of this solution. So we knew we had to get to this level so we could jump over to magnesium chloride using the stoichiometry. And once we got to this point, we used the concentration to figure out what volume we needed. So I hope that's clear to you. Watch this a few times if it's not. Make sure you understand how to do this and work it yourself, because a lot of problems in subsequent sections are going to be that way. You're going to have a concentration of some solution. What volume of it do you need? Usually you're going to have to calculate how many moles of something you need and use the concentration to find the volume. But it's all going to come down to these unit cancellations. So make sure you understand that technique, because as I said many times, it will save your bacon, and it is one of the most useful things that I've ever learned in all of math and science. So make sure you understand it, work this problem. Follow me on to the next section. We're going to begin to talk about acids and bases and how they react, which is a super important class of chemical reactions.